lieutenant colonel. He went to the United States Naval Academy, was in the class of 71, and he specialized in German studies. Served in the Marines from 71 to 96, A6 Bombardier Navigator, Olmsted Scholar in Germany, and Luftwaffe General Staff College. As part of the Lockheed Martin Skunk Works, I'm sure he can tell us about what Skunk Works are, from 97 to 2015. K-35 Flight System Safety Engineer, F-35 Tactics Development Analyst, and Advanced Systems Development Analyst. So help me welcome Mr. Jerry Guy.
Thank you very much. I'm very excited and very pleased that I can come here and talk to you all about this. What I'm going to talk about today, the topic is aircraft carrier flight operations. This is important. Aircraft carrier flight operations is what separates the United States Navy from every other Navy in the world, quantitatively and qualitatively. Because other navies in the world, they've got cruisers, they've got destroyers, they've got a lot of small boats out there. There are other nations in the world that have also nuclear powered submarines that shoot ballistic missiles and surface missiles. They do not have a carrier capability anywhere near the United States Navy. You can see up here, we have twice as much deck space as any of them. We now have 11 aircraft carriers. They can go anywhere in the world that they want. The freedom of the seas, and they can take and project that power ashore. They can go out and make the friendly skies as friendly as they want them to be. Other nations are trying to establish an aircraft carrier force. They've got a long ways to go to match what the U.S. Navy does. Any weather, any time, any place. And that's what we're going to be talking about today. My background, well, I guess I can show you better than anything else. That's pretty much what I got in my introduction there. There's an image I have myself right there. But I did a lot of time in Germany, but my main focus in life was the A6 Intruder. It was an all-weather bomber. It was one of naval aviation's world aviation first. No one in the world had an aircraft like the A6 Intruder, and it was a marvelous airplane to me. I lost my sight went bad at the Naval Academy, so as I had to become a naval flight officer, and this was absolutely the best airplane I could be in as a bomber. You can see I spent quite a bit of time in Germany with studying over there and doing time with the Luftwaffe. Had a 2-year tour with them. It qualified me for work in safety on X-35, the F-35 Tactics Development, and Advanced Systems at the Lockheed Martin Skunk Works. If you're not familiar with the Skunk Works, that's the research and development arm of Lockheed Martin. They're the ones that made the U-2, the SR-71, the F-117 stealth fighter, and many, many other projects. They continue to do that. I was very privileged to take and do that at the second part of my career. These are the topics we're going to be studying today. The aircraft carrier will look at the deck and the people that run it and what a battle group really looks like. We're going to talk about the aircraft system, how we launch aircraft on an aircraft carrier, and most of the technical aspects and the operational aspects. We're also going to talk about aircraft recovery. Launching, you see, there's a lot more that goes into recovery, and there's a lot more pilot control involved in that. You can see we're going to go through a lot of different technical aspects of getting the airplane back aboard the deck. The hardest thing you can do with a jet is try to put it on an aircraft carrier that's waddling around out the ocean. Now we're going to have to once we get through with all this topic, then I'm going to show you some videos here, so you should be able to watch this the video on the launch and recovery and understand most of what you're seeing out there. Okay? Any questions? Aircraft carrier, first and foremost. We have 10 Nimitz aircraft carriers, and there's the list of them right there. We now have the Ford class that's coming out there. That's our 11th aircraft carrier. I did not fly off this aircraft carrier. I flew off the Forrestal class, which is similar in size, but these are much better. They're nuclear powered. We had a conventional powered aircraft carrier on the USS Ranger. A bit smaller, the deck is not laid out as well, and some of the systems were old, but it was still an extremely capable ship. We celebrated her 30th anniversary while I was on board. So, we're going to concentrate on the Nimitz class. That's what it looks like overhead. And I'm gonna go over the flight deck here, as a matter of orientation. Can you see around me okay? First of all, here's all the data right there if you wanna get the numbers. I'm not gonna read those to you. There are 4 catapults. Catapult 1, catapult 2 on the bow. Catapult 3, catapult 4, they're on the angled flight deck, or what we refer to as the waist catapult. There are also, in back of every one of these catapults, there are jet blast deflectors. Those are, it's a barricade or deflector of steel that's liquid cooled to can stand the temperatures from an afterburner. They come up at about an 80-degree angle, and they're extremely effective at taking that jet exhaust and directing it up into the air. You can bring a jet aircraft in right here in back of the jet blast deflector like that, while there's a guy in full afterburner here, and it's perfectly safe. It'll shake you around a little bit, but it is a perfectly safe operation. Keep people from being blown off the daggers. Now, this is the landing zone right here. You can see the white on either side are the limits, and down the center there's a white and yellow streak to mark the center line of it. Very hard to see here. There's also a red and white line around here, several of them around the deck. Those are the foul line. If anyone's over there, operation stop. You don't launch, you don't land. That's because it's too dangerous. When you're out there on the aircraft carrier, safety is the most important thing because everything out there is extremely dangerous. Now, other important points here. The Fresnel lens. We're going to talk about this in detail later. The Fresnel lens tells the pilot very precisely where he is in relationship to the optimum glide slope that will put him down in the middle of the touchdown zone. That's where these wires are right here. 1, 2, 3, and 4 arresting wires across the touchdown zone. And each one of those is capable of bringing that aircraft, any aircraft, to stop in about 400 feet. The Fresnel lens, if you fly it correctly, you'll touch down between the 2 and the 3 wire. On the more modern aircraft carriers, starting with the Reagan, they only have 3 wires now. So they target the center wire because it's less people and the more reliable system. And aboard ship, they don't like it when you land in the first wire anyway. So, the other thing we have is that's a Fresnel lens. It's all the way down. You can see 2/3 to 3/4 of the way down the flight deck, which means the pilot can see that optical landing system all the way to touchdown. And he should be watching it all the way to touchdown. Not the deck, but that optical landing system. Landing signal officer. Yes, we still have that. Actually, it's a team of landing signal officers. The landing signal officers, they no longer wave flags. You saw them in the World War II and Korean War movies where they're giving us all these waving their flags. Each one's a different symbol to the pilot. We don't have that anymore. Now he has a radio telephone. He's in back of a wind break, and actually there's a whole team of them out there that do the controlling of the aircraft. Now he's on a radio telephone. He talks to the pilot. We'll go into that when we get on later. He doesn't wave a flag, but he talks to him and does other things out there. They're absolutely vital to landing aboard that aircraft carrier. Then we have the air boss. He's back here on the rear of the island, and he's in charge of everything out here. Everything on the carrier deck, he's in control of, and he controls the area around the aircraft carrier for 5 miles, up to 3,000 feet. Any questions about the aircraft carrier? Okay. Flight deck personnel.
I have a quick one. On the slide before that, you had the list of your 10. Who was Carl Vinson? And everyone was a president.
I'm not sure who Carl. I think he was a defense secretary of defense, and I think Stennis, another guy, secretary of the Navy. I've often asked, well, who are these guys? You know, usually you'll name an aircraft carrier about something that's historic significance. Enterprise. We've had a lot of enterprises out there. Constitution. Well, we don't have a constitution because the Constitution is still on active duty in Boston up there. Old Ironside. And presidents, Eisenhower, Truman, Kennedy. I don't know why they named it Stennis because I don't know if it must have been a big shot at the time, but that's what we have. We used to have carriers for Roosevelt, both Roosevelts. We still have the Teddy Roosevelt out there, but I don't know where Stennis and Vinson and Stennis. I know these other guys, but I'm not sure why they do that.
Carl Vinson was a politician
a politician.
Yeah, but he was also, influential in the development of the United States Navy.
Okay. Wow, good. Thank you. Flight deck personnel. John Paul Jones up here. Men mean more than guns in the rating of a ship. Well, you would have said, nowadays you would have said men and women, because the women we have nowadays are a lot tougher than the ones back there during the American Revolution. This is what makes the aircraft carrier work. I cannot emphasize that enough. Here, everyone on the flight deck, it has a reason to be on a flight deck, wears a colored jersey, like you can see here. If you want to get all the details, they are listed right here, what the jobs are and what they wear. Prime importance, yellow. These are the guys that are taxi directors. Now, taxi directors, when you're on an aircraft carrier, you do not taxi that airplane unless you're under the control of a yellow shirt. Yellow shirts give you hand signals like this. Everything's done with hand signals out there between the deck personnel and the pilots. If the pilot does not see a controller, is not sure which is his, he'll stop the airplane. If an aircraft doesn't respond to the handler signals, he'll give him a signal like this. They love doing that to officers for some reason. But they move them around the deck because there's too many obstacles, too many aircraft, too much day personnel out there. Green jerseys. These are important guys. They do the catapults and the arresting gear. They hook the guy up and they hook the airplane up and they retrieve the aircraft. They're a very dangerous job because they're out there when the airplane is actually being launched and when it's being recovered. Purple guys, they give the fuel. They're the ones who fuel the aircraft. Blue shirts, those are guys that push and pull the airplanes, move them around the deck, and they do that a lot of times in coordination with the yellow jets here. Maintenance guys wear these brown, and crash, fire, and rescue wear the red, and other observers and medical, they come in the white. That's basically the way it was all set up. If you looked at any videos of the Chinese Navy, and there's embryonic efforts at making a carrier Navy, they do the same thing. They have all these color-coded jerseys on there so you can see who's out there and if someone belongs there, okay? Skunk Works tip. When I was aboard, one of the top engineers I worked with on Lockheed Martin Skunk Works told me one time he went out to an aircraft carrier. Lockheed was great that gave him the opportunity to go to an aircraft carrier. And I said to Steve, when you got on that aircraft carrier, he's one of the top engineers. What did you impress you most about the aircraft carrier? And without hesitation, this top engineer, I thought he'd something like catapult, rescue gear, something like that. Without hesitation, he said, Jared, what impressed me most, everything important to launching and landing an airplane on that deck was being done by a 19, 20-year-old sailor. And by golly, Jerry, he just wasn't just doing that. He was doing it as hard and as good as he can. Everywhere I looked, I went down below the deck where I saw this one sailor doing the thankless job of greasing the cable for the arresting gear. I said, well, what are you doing, sailor? I said, oh, sir, I got to get this right. I said, I don't do this. You can have a cable snap and someone's going to get killed up there on the flight deck. Everyone was like that. So I've told that to many naval aviators, everyone aboard the ship. They said, boy, that was really a smart engineer, because that is exactly what it does. John Paul Jones knew what he was talking about, and it's still true today. Questions? Okay. Deployed flight operations. Okay. The aircraft carrier never goes low. This is Donzo Station here. This is what I did when I was on board the aircraft carrier in North Arabian Sea in 1987. This is my Battle Group XO, USS Ranger, and CVW-2, the carrier airway. Now, this is a long time ago, but take my word for it. We will go someplace, we go in a battle group all the time. What we had out there, the centerpiece is the Ranger. That's our striking power right there. We have cruisers with guided missiles out there to give close-in guided missile defense. We also have, they can augment that with destroyers out here that also have an anti-air capability, and they also have a anti-submarine capability. Submarine, you talk to a guy aboard an aircraft carrier, he's more scared of submarines than he is airplanes coming in. We can handle airplanes. Submarines, they are the ultimate stealth weapon. They were when they were first invented, and they remain that way today. Also, logistics ships, oilers, and fleet supplies. When we're underway, You know, these are the guys that bring the food, it's absolutely is important. You run out of food, you run out of oil, you're out of, capability. A special note here, while we were over there on Gonzo Station, the USS Missouri, my home state, BV-63, that ship was giving gunfire support to my dad when he was a Marine on Okinawa back in 1945. And now she was recribbed and she was out there working with us. And she was a sight to behold. Don't have any battleships anymore, but it was really neat. So we essentially, with that surface action group, we had a battle force out there.
That's the Missouri that was used to,
For the treaty.
for the Japanese to sign their
Yes.
unconditional, surrender, yeah.
Yes. If you ever go to, if you go to Pearl Harbor, be sure to visit the USS Missouri. It's an incredibly rewarding experience to stand on the deck where the treaty was signed and to see where the Arizona Monument, where the war started, where everything like that. Okay, so the Battle Group Echo is controlled. Any battle group has a Rear Admiral United States Navy commanding. Like I said, with carriers, cruisers, destroyers, submarine, I'm not really sure. I hope they have a submarine out there. They never told us there was a submarine with us. But you know, our nuclear powered subs, they can stay underwater a long time. But I was always suspicious because every time I had ordnance, I had to jettison. Say, I'm right here, I'd like to jettison. No, jettison it over there, we'll give you a place to it safe. There's no one under, go over here. So I kind of think that they had one out there. I hope so because now, like, countries like Iran are getting submarines and there's no better weapon against a submarine than another attack submarine, especially U.S. attack submarines. My roommate in the Naval Academy, he was sub-commander of an attack submarine. He was a sneaky guy just like all those sub-commanders. Carrier, the Ranger is commanded by a captain of the United States Navy, okay? And aboard there, the striking power comes from the carrier air wing. He's the captain of the United States Navy, commanding the air wing. We had 70 plus fixed wing, rotor wing aircraft. Most of them fixed wing. We were an all Grumman deck at that time. We had 2 A6 squadrons, 2 F-14 squadrons. We had an EA6 unit. We had an E2 unit. I should say. And we had an E2 unit aboard there. So we just had, that was just the way we configured. All these are configured the way that best fits the Navy's needs. And now just about everything is F-18s and F-35s, switching over to F-35s. When you're over there, you talk about the flight deck is often referred to as the roof. Airplanes that are ready to fly, they're undergoing routine service, or they've got maybe some maintenance that can be handled by the squadron level, they're on the deck up here. An aircraft that are below on the hangar deck, they're down there if there's intermediate level maintenance, like a phase maintenance they have to go through every 50, 100 hours, and are aircraft that have been hard down for some reason, they're not going to be considered to be flyable for a long time. They go down and there's 4 elevators, I think you might have seen them on the slide there with the flight deck. To bring them, we could bring aircraft up and down. Any question about how we deploy like this?
Do you have any idea how many people it took to man all of
Oh, for the entire battle? No, I do not. You can see from the previous thing, we had right near 5,000 people. Air wing with about 2,500 and about 3,500 on the ship's crew.
Honestly, there's probably more on that carrier than all the others put together.
It may be, yeah. I think you'd have maybe 300 aboard a destroyer,
what I'm saying.
probably
You don't have
400
that
on
many.
a cruiser, something like that.
Maybe 800 on the Missouri.
Destroyer's about 305, I was on them, I can tell you
On
that.
which one was that?
Well, the Kieran class, which were the older ones.
Oh, okay.
And the 305, anywhere from 270 to 305, depending on the class.
Yeah. There's someone with a calculator out there do the math, but I still like the editor.
Couple of Army divisions.
Oh, by the way, those are the elevators I mentioned. We got 3 and 4. They put them on an edge. Another British invention. They put the elevators on the edge. It's much more efficient way to do things. Okay, so let me emphasize. When the Navy goes out for training, they might just have a destroyer out there to be plane guard. His job is to rescue anyone who jumps out when they're trying to land on the aircraft carrier. But when they go out like this, when you're deployed on a full-scale deployment, that's what they look like. They're spread out a lot more than this real nice photos they took at that time. But that battle group is ready to go to war, and I mean right now. It's fueled, it's armed, and it is ready. You say general quarters, In about 3 minutes, everyone's ready to go, and that thing is ready to go to war, any place in the world. And like I said, the world's covered with oceans, and there's no policeman on the oceans. The closest one to a policeman is the United States Navy. Okay. Next topic we're going to talk about is aircraft launch. Now I'm going to mention something called cyclic operations. Cyclic operations is the way you get the most people airborne, and it's critical that our pilots fly, because flying, as you know, is a perishable skill. Landing on an aircraft carrier is very perishable skill. When you're deployed, they try to get everyone in the air. On every flying day, and there's some days that you don't fly, but on every flying day, they try to get you, I always say, 1.5 hops. Because one day you'll get 1 hop, and one day you'll get 2 hops. So that's the way it'll kind of average out. A big thing that's involved there is, if you have not flown a night landing in 7 days, you are no longer qualified to do a night landing. This is how serious the Navy takes that night landings out there. You have to go through a day landing on that day, and then you can do a night one. So, but they're really serious about that. So, cyclic operations gives the widest use of the airplane that most people can get in the air, and it keeps the deck working the entire time. The guys that run the deck there, they need to be their skill. They need to keep their skill level, just like the guys. First, getting airborne. Steam catapult. During World War II, we had hydraulic catapults, but you know, a lot of times you didn't need a catapult at all. Power goes up, propeller-driven airplanes take off at a lower speed, run down the deck, you're airborne. If you're heavy, they had a hydraulic catapult that would boost you up. Hydraulic catapults were used in the Korean War. Bridges to Tokyo, great movie. You'll see a lot of the limitations with straight flight aircraft carriers. The Royal Navy, they invented the steam catapult. They shared our technology with us. So let's go over this. First of all, underneath the deck, there are 2 pistons. You can see mock-ups of them up on our flight deck display here in the museum. They ride in cylinders, they're attached together, and the attach mark comes up to the top through the deck of the aircraft carrier, and it's attached to something called the shuttle. Well, the shuttle is right here, and you can see on the nose gear of every naval aircraft, we now have a launch bar. And that launch bar, I just lost my bead.
Mickey is mine.
You got it, lady?
You can try mine, but mine does the
These
same
don't
thing.
show up, the red doesn't show up here very well.
I'm not gonna say it'll work any better.
Yeah, the red ones don't show up really well.
No, mine's not red. What's in here?
$100 million aircraft.
I know, right?
Need a ribbon?
That's okay, I can just point this up.
Need a ribbon?
Is that, no, let me try. Oh, isn't that cute? Yeah. Uh-oh. No, I apologize, I can just point at it with it.
Yeah, we can follow it.
I used to carry a pointer with me too. Okay, steam comes up like this, like we said, goes through them, and there is the launch bar. All right. Now, it attaches to the nose strut. Now, the aircraft needs to be restrained on the catapult. That's because when you open the valve to energize this and put the steam in here, steam does not build up enough power to launch that airplane instantaneously. It takes a time for it to build up. If you didn't restrain the airplane, steam would go in there, the airplane would be pulled down the deck and dribble off the deck and fall right into the ocean. So you have to restrain it. And you cannot restrain it with just brakes, okay? Because an afterburning jet, you cannot hold an afterburning jet just with the brakes. So what they do to restrain it is they add this device right here. It's a holdback bar. One end is attached to the deck of the aircraft carrier, and the other end is attached to the back of the nose strut, just like you can see over there. Now, the link that makes that connection right there looks like this. It's called a holdback fitting. Now, if this little dumbbell looking thing, or dog bone like this, is precisely made. This neck right here is machined down so that it can hold that aircraft and restrain it at full military and full afterburning power, okay? It is not strong enough to hold that aircraft when the catapult has full power. And that is a safety device, because to ensure that there is enough energy to launch the airplane, steam has to go in and build up enough power to snap this in a pure tensile fracture. It'll snap that, and then that lets the airplane go. So they put steam in there, but it's not going anyplace until this thing breaks. Now, they do have electronic versions of this now, but I'm from the old school, and this is the mechanical solution they have, and that thing brings up. Is that clear? Does that explain everything? So it's very good, important device.
Kind of looks like it's made of plastic.
No, it's made out of steel,
Yeah.
some kind of steel compound or, that they have, and precise.
It's not PVC.
So, no, it's not. I've got my first catapult shot, of course, to keep that, everyone does. This right here, so the sequence then is, the steam comes up through here. Nuclear carriers, reactor, all it does is make steam. Makes a lot of it. They fire that up here, when it's ready to, when they hit the button, it lets the steam come in. It builds up power, snaps the whole back fitting. The aircraft goes rocketing forward, and it takes off, and you can take a 60,000-pound airplane and take it and from 0 to a safe flying speed of about 175 miles an hour in 2.5 seconds. Folks, it is like getting shot out of a gun. It's more fun than any other ride I've had at the amusement park. A little more intense at night, but it's really a fun ride. Now, the last piece of this engineering miracle is the pistons here. The airplane flies away 175 miles an hour, but those pistons are still traveling 175 miles an hour. So, you have to be able to stop them. What they have is an ingenious device called a water brake. That's this right down here. Now, the pointy ends of this thing, the tapered ends are like that, they go into the cylinders that are full of water. Now, the water is incompressible. So they go in and squish that water against the casing. And so the energy is transferred from from the pistons into the water brake. Well, that energy, when it's absorbed, it's a tremendous amount of energy. So it will shake that everything that's metal that's attached to it right there. And it transfers the energy to the hull of the ship. The deck plates are attached to the hull of the ship. So when that water brake hits, you can feel that wherever you are in the aircraft carrier. Most remarkable thing, first time I went to the ship, I felt this, I watched a guy launching on the deck, and there was a boom right at the end. I could feel it in my feet. You go aboard the ship, and that's how much kinetic forces there are to catapult a 60,000-pound airplane. So that's how we get on aircraft launch. Any questions? There's a procedure to launching. Okay, let's go through it right here. Read through the actual steps right here while I go on. First of all, yellow shirt comes out when they're ready to go. They taxi you using hand signals. They will taxi you out and get you lined up on the catapult. Once they do, they'll drop the launch bar down. The green shirt comes in and he hooks up the whole back fitting. He gets the launch bar hooked up. Now, once he gets everything hooked up and it's ready to go, he gives a thumbs up to the yellow shirt that's just gotten lined up. That yellow shirt will then give a signal to take tension. You can see what he's doing, like a hand throwing like that. That means take tension. When they do that, they're putting a lot of steam, or some steam, into the catapult. Because you can see these fittings, they have to be all tensed up and everything in order to carry the load, right? If it wasn't tensed up, you could snap everything apart with this tremendous amount of energy. So as soon as he does that, the pilot goes to military power. And the green shirt, he runs out of there because he's standing in front of a cock pistol with a finger on the trigger. He ain't gonna spend any time more there, once that goes. After he does that, the pilot's at the military power, then he will turn it over to the catapult officer. The catapult officer is the star of the show. No airplane flies unless he says it flies. He'll come out there and he'll give the same signal or similar signals. Two signals turn up like this means give me military power, make sure they're there. Then he gives the signal, if it's an afterburning airplane, afterburner, like this. Now it's plugged into afterburner. Now, things happen fast, he's burning a lot of gas. He'll point one finger out at everyone down there and they start He wants to see a thumbs up from everyone out there that's observing it, and he wants to see it right now. If he doesn't, they're gonna stop the launch. So he sees a thumbs up from everyone, then he looks up at the pilot. If the pilot's ready to go, he gives a traditional hand salute, request permission to leave the ship. Pilot salutes back, then the catapult officer, when he sees that, he will salute back. He'll take one more look at these jets down here, make sure everyone's got green, and then he gives an unmistakable signal that tells everyone on that ship, this catapult's gonna fire, stay clear. And that is a signal like this. He'll take his hand, and he'll bend down to his knees and touch the deck. Now this is a preparatory signal. Everyone knows the catapult's gonna fire. The actual signal to fire the catapult is when he snaps his hand up like this. And that's because ships don't sit still in the water. They pitch a lot, okay? And he wants to time the launch of that, the buildup of energy and snap the whole deck thing, to match the pitch of the ship, because he wants to have that thing fire when the ship is pitching up, not down. We want to launch airplanes, not submarines, right? So that makes sense? We'll take a look at that later on. So, he gives a signal, press the button, steam fills up, the whole deck breaks, the airplane goes rocketing down the deck, just like you see there. He flies away and the water break hits. What could be simpler, right? That's how we launch an airplane with the aircraft carrier. Any questions?
Who's controlling the catapult and everything?
Okay, you've called my hand. This is the way we used to do things now, because there'd be a green shirt on the side of the deck right there, okay? When I went in the older ones, and he had his hands up like this. Now there's a button, he reaches down. He's got his hands up like this because if people are on that catapult, they wanna make sure he ain't got his hand anywhere near that launch button. He's the guy that does it. Now there is sort of a cupola, and the catapult officers stay inside there and they actually control it themselves. And they have electronic, it's kind of, the way they do things now is more modern, it's more safe. It's just not quite as colorful, but that's the way we used to do things, and that's where I agree. Now the catapult officer actually can hit the button. I guess I'm an anachronism, so. Okay, when you're doing cyclic operations to get the maximum number of people in the air, you have to go about a certain sequence. Now this is the sequence, and you set up to begin the flight day. Now, you can see the deck here, where it is red. These are where the aircraft are parked, ready for the launch. They're not parked haphazard. They position everything for the launch, the first morning launch. And they position so these aircraft, or this catapult can't be used because there's aircraft there. They taxi around like this to get on this catapult. Right here, already in position, are the helicopters. Because they're the safety factor, they launch those first, and the next airplane to go airborne is going to be the E-2, because that's the eyes of the fleet. In my mind, it's the most important airplane the aircraft carrier has. Everyone else is going to be launched on what they call an event. It's parked like this, or the first and second event, so they can quickly get up here, cross over the jet blast deflector, and get hooked up to the catapult. Okay? So it's important that they're like that so they can quickly move the airplane from its park position to the launch position, or to the catapult they want to fire it off. So this is basically the way we do that, and how it's controlled. Helicopter launch, and then the first event launch. Now, in an event, that is, generally speaking, every squadron on a ship gets to fly an airplane, or maybe 2 airplanes on an event. So if you have 10 squadrons, you know you've got, probably unrealistic, you've got 7 squadrons aboard there, that means 14 airplanes are going to launch off an event. Right? So that's basically how it would be done. So the first event, they move them quickly in position, they're already on the catapults, they start launching, and then the other ones in the event start moving up there to get their position. The first event launches. Everyone's airborne, and they're on a cycle. Probably now, I think they're on a two-hour cycle, hour and a half or 2 hours, meaning that after you launch, about an hour and a half or 2 hours later, they're going to bring you down to land. Okay. Now, while they're up there doing that, they come. The second event gets ready to launch and gets positioned. What they do is they will launch the second event before they recover the first event. Because if they do that, there's a lot more clear space on the deck for landing airplanes and getting them over the foul line so they can continue to land, right? Now, that type of sequence continues all the way throughout the day. First event recovers, third event launches, second event recovers, fourth event launches. And that's repeated all the way down till the end of the day, the last event of the day. And the last airplane to land will be the recovery tanker. In every event, there will be a tanker aircraft that takes off. Because anything can go wrong at sea, and if there's any delay, you want to be able to put some gas and give guy an extra fuel. So that's what they do, and they check the tankers to make sure they are what they call sweet. Okay, so the tanker actually works. So they have that, and so I've been the last tanker. I've been more often than I really wanted to be, but you're the last guy up there, the last fixed wing flying. You landed in a helicopter land, and then the ship goes on its merry way. Now, all of this is done, launching and landing is done at one time, and they do it as quickly and expeditiously as possible. Daytimes, they're looking at 30 seconds between aircraft, okay? And night, 40 seconds. And why is that? Well, it's because this airfield, like any airfield on the land, airplanes have to take off and land into the wind, okay? However, this airfield also has to go someplace. And Mother Nature never cooperates. It seems like every time we're out there, we gotta go someplace. Mother Nature makes the wind blow from the opposite direction of the direction we have to go in. So the ship may be going 20 knots in the wrong direction and has to make that up. It'll have to make sure it goes to the spot where the guys that just launched are gonna look for their recovery time. So that's why they do everything as expeditiously as possible with the ship. So this is the cyclic operation, the launch and landing procedure. Any questions? Good? Okay. Recovery. This is the most important part of it and the hardest thing to do. Again, we're talking cyclic operations that fits in with that graphic we just had before. Other than the pilot, the most important person out there is called the landing signal officer. He stands on the back just like he did in the days of World War II and Korea, but instead of flags, like I mentioned before, he has a radio telephone you can see down here. He has a wave-off signal that he can signal the pilots to wave off, in addition to verbally giving them a command. You can see he has a whole team out there, and they have controls to tell them what the ship is doing, what the wind over the deck is, the crosswind, the pitch of the ship, all that information. These guys are highly trained and they can observe the airplane. And they can tell the pilot what's happening with his airplane before he can see it. He'll give them advisory comments like don't go high. He'll give them mandatory comments like power. He controls them all the way down verbally. Every time an LSO, there's one controlling LSO there. Every time the controlling LSO controls a group, he goes down to the ready room and talks to that pilot immediately after the landing, because they debrief him on what he did, what his grade was. Every landing is graded, and he tells them what your grade was for that landing, and he looks for any sort of trends out there. Says you could have done this better than that, and that's important. Navy's not nearly as worried about losing an airplane as they worry about losing a ship or capturing a ship, because everyone who comes across that ramp, they bet the house on everyone that's coming out there to land. That's how critical this is. So that's what the LSO does to ensure continuity and high quality of aviator landing.
Is there any assistance, electronic assistance to help the guys land and for the deck crew?
For the deck crew, not so much, but we're gonna get into the assistance, what helps the pilot. We're gonna get there, okay? And actually, we're right there right now. Landing speed, as you might think, is absolutely critical aboard an aircraft carrier. You have to come down at a set speed. And the speed aboard the aircraft carrier, landing on an aircraft carrier, is controlled by angle of attack. Angle of attack is much more precise than the airspeed indicator. Now what is angle of attack? That's the angle between the traveling wind that's hitting the airplane and the wing, the lifting surface, okay? So, and he has indications, as we can see right here, He has a number of indications inside the cockpit that show him what his angle of attack is. There's an indexer up here on the windscreen, right next to his faceplate. See it right there. There's a green chevron that points down, a round one that's yellow, and a red one that points up. This indicates he's on perfect speed, optimum speed. If he gets a green chevron, it's pointing down, he controls the speed by dropping the nose. Just like going downhill, you go a little faster, right? Just the opposite. Going uphill, if you pull up a little bit, you go a little slower. So if you're fast, you get a red chevron there. So he's controlling his his speed with the nose of the airplane. Kind of backwards, usually you think you pull on the stick and point that where you want to go, right? But this is what he does for his approach. He flies that angle of attack. Now, this is what it looks like inside the cockpit. He also has an indication down here, an index on the HUD that tells him his angle of attack. So if you put all these together, it looks like this right here. On speed is the donut, and on the HUD, he has a thing that looks like an E. And you can see his impact symbol right here, it's level with it. That means he has a round donut there, optimum speed. If the airplane comes up here, he'll get gets a little slow. You'll see a green chevron above the donut, meaning get yourself back down. And this matches this symbol right here. You can compare these, as you can see, right on his HUD and the indexer. If he's really slow, then he gets just a green chevron like that. And you can see where he is on the E. Slightly fast and faster down here, and they're just the opposite. Does this all make sense to everyone?
That reminds me of the red over white, whenever I'm learning to fly. And the red over white.
Same thing,
they're all
just a lot more
right,
precise than
exactly.
that.
The same advanced technology,
Yeah.
angles that are ankle.
Yeah, it's angle, but like he was saying, this is much more precise than the VASI system. Because you're coming in, there's a setting for every airplane out there, they figure out the optimum angle of attack for landing that airplane. And the pilot flies it with the nose of the airplane, okay? Now, this is all the pilot out here. Notice if you look here, if you look real close, you might see slow, green chevron. You see the green up there? There are lights on the front of the aircraft, and these are used mostly for night operation. Because at night you can't get a clear view of him. When he's on speed, there's a yellow one right there, yellow light comes on. And if he's fast, you get a red one. That's not what the LSO really looks for though. Landing signal officers will look for something physical that's absolutely positive, and that's what you see here. Look at the canopy right here. It's even in a line with the fin tops. That's on speed. That's what the landing signal officer looks at. He looks at this and where the nose is going. That's why a good landing signal officer, he can see, anyone, the LSO can easily see 5 knots of change. And he'll see it before the pilot does, because he can see this relationship. Can you see here how the canopy bow is above the fins? That means the nose is up, it means he's getting slow, right? And if he's down here, look at the difference there. Now, he can see that he's fast here. So you can see the airplane coming in, and that's what the landing signal officer will look at. He won't rely on just the lights. So inside the airplane, that's what you get. LSO is looking at this right here, and that's how they control the speed precisely all the way down the touchdown. It's kind of checked for good. Much more complicated than launching, isn't it? Questions? Okay. The other device we have for landing aboard the aircraft carrier that helps the pilot immeasurably is the Fresnel lens. Okay. This was first of all, this optical landing system was invented. It was a mirror used by the British. We copied that and we made it better because now it is a series of Fresnel lenses. Fresnel was a French physicist, and he made what's called the Fresnel lens. That's what makes a lighthouse a lighthouse. It can take the light and spread it into and concentrate it into a beam. These are overlapping Fresnel lenses here, and they result in a yellow ball right there. Now the pilot wants, and the other lights on there are datum lights. A line of lights right here in green, so they're unmistakable. They represent the optimum glide slope coming into touchdown. Okay. Red lights are for wave off. If there's a dangerous situation, the airplane cannot land, the landing signal officer will hold those up like that. You saw the picture? He'll use that to flash those red lights, and he will talk verbally, wave off, mandatory call. So, this is how it works, what the pilot does as far as controlling his height. He controls height with throttle. Gets the airplane trimmed up, and if the ball is right here, even with the datum lights, he's on that precise glide slope, right around 3.5 degrees, okay? If he sees the ball up here, he knows he's above that glide slope, okay? And if he's up there, he reduces power, the airplane settles till it comes down there, he tries to catch it and adjust his power. If it's low, just the opposite. Now he adds power, the airplane climbs, the ball goes up, okay? So, that's what he looks at. This display is good for at least 3/4 of a mile in the back of the ship, and it's very precise. So that's what he's doing. So it's funny, he's controlling his speed with the nose and height with the throttle, which is kind of backwards to the way most people would fly an airplane, right? But that's what they do to give you a precise landing capability. This all make sense now? Good to go on? This is a consolidation, so you can see basically what he's going to see out there. There's the E, his impact point. There's the carrier landing right there. The meatball's right here, and you can see he can get his altitude, speed, indexer, and compare it to this, all in one quick view of the pilot. So that's what he sees when he's coming aboard the aircraft carrier. And at night, it's getting scary when you do it at night. Anything? What does this look like when you put it all together? Well, this is what it's going to look like. This is inside the cockpit. Now remember, altitude, throttle. Airspeed, stick. And of course you're going to be doing line up like this. So it makes kind of a busy cockpit here. Notice the throttle goes to full military. What could be easier, right? It's pretty busy back there. In 3 seconds when you're back at 3/4 mile in back of the ship. That's what it looks like. How does he get there? During the daytime, the airplanes are ready for their recovery. Remember, everyone recovers at the same time, like we mentioned earlier. The airplanes are called down at what they call a Charlie time. Signal Charlie, come up here and start coming down. 5 miles in back of the ship, they get up to 800 feet, a flight will come in, usually it'll be at least 2 airplanes together. They come up to the bow of the ship. They're doing 250 knots, maybe a little more. They'll do a break over here, descend to 500 feet and trim the airplane up to land. Make a call to beam to who the pilot is and what type of airplane it is. So now he's down to 600 feet. When he's abeam the stern of the ship, he starts his turn in. And he'll roll out down here about 1 mile in back of the ship. And that's where what you just saw, when he starts operating the throttle and the stick together and flying the ball. He'll come down, make an arrested landing. If he doesn't make an arrested landing for a mistake, for any reason, they call that a bolt if the hook doesn't engage. He'll take off, get up, and then come back down and rejoin the pattern, picking up the interval of the airplane. Okay? This is what he did. Those are the steps over here. And you can see. When he gets at this point, I probably should have mentioned this, he calls the aircraft, intruder ball and the type of amount of fuel he has. Intruder ball 5.0. LSO responds, Roger ball, intruder, looking good. And then he flies the ball into touchdown just like you saw. It comes out to be meatball, lineup, angle of attack, all the way down to touchdown. When he gets there, this is what it looks like daytime. You can see the touchdown zone there where the arresting head cables are. You can see the meatball right there. You watch that all together. You can see right there, he's got an optimum right on altitude, right? Right on the glide slope. The LSO's over here. cross-check pendants here. The air boss is up here, he's watching everything that's going on. These are drop lights, they're used mostly at night to give you an idea of your lineup. So they're not really used that much during the day, you'll see that how they're used at night. So that's what he sees when he comes down after he gets off the ball and starts flying like he just saw. What about night? Night or bad weather, it's always what they call case 3. Now you'll see here those familiar flying. This is an approach plate, just like you have an approach plate for coming in and doing attack and approach at any field. And you'll see it outlines all the details of that flight. And you'll see that the airplane comes down on the approach, and its relationship to the final bearing. That's where the lineup of the angle deck is. Okay, so they do everything with the spots to the angle to the final bearing. They do a descent, come down here to get to 10 miles, 1200 feet, get into 3 miles, begin their final descent, and at 3/4 of a mile, they get the GCA type of approach. It's called the carrier, CCA, carrier controlled approach. They give them advisories all the way down to where it comes in close. Then 3/4 of a mile, okay, 3/4 of a mile, call the ball, and then it's visual from that point on. This is how they set up for it. To do a night recovery. When they do night recoveries, this separates the men from the boys. Everyone lined up here on the final bearing. They put one nautical, each of the aircraft is holding individually. Okay? There's 1 nautical mile and 1,000 feet between each aircraft that's in the stack. Okay? All of that in the event is in the stack. They push 1 minute apart, and they descend at 4,000 feet per minute. See, that's this line right here. When they get down to platform at 5 miles, when they hit platforms at 5,000 feet, that's a wake-up call. They call platform, and then they decrease their descent to 2,000 feet per minute. Okay, and then they fly that approach in until they get into that spot 3/4 of a mile, and call the ball. Then they fly visually onto touchdown. If they get a bolter, the airplane gets back in the air again. They don't get a direction for some reason. Climb straight ahead, 1,200 feet, and then they'll circle back around like this. And the carrier control, aircraft carrier control center will work them back into the cabin when they have a capability to space it. And that's what it looks like at night. Don't have a very clear picture of this. I don't know if we snap that picture at night, but that's the best I could do. These are those drop lights. You can see there's a little bit of an angle between there. It should be a straight line here. The Fresnel lens is over here. But the important thing, the big difference is, he's flying good solid instruments all the way down to that 3/4 mile point. And then he's visual. He's got to fly a visual approach, and his only attitude reference at night is that triangle, is that rectangle right there, that trapezoid. That makes it extremely hard for anybody to that's what you have to do.
What's done to compensate for the pitch and roll of the aircraft carrier?
Boy, that's a good question. The LSO knows what it is. And there are systems, they do have automatic carrier systems, and they do have something called deck motion compensator, the one that I had. Those systems are much better now. But back in the day, and most of the time now, when you come in flying a manual approach down there, the only thing that really compensates for it is the landing signal officer. And I'm going to show you, I'm going to give you an example of that in a few minutes here, okay? But essentially nothing. It's manual. Okay, the recovery sequence now. We looked at the takeoff sequence, now the recovery sequence in cyclic operation. The aircraft touches down. The pilot applies full power, because if the airplane bolters, if he doesn't get an engagement for any reason, he wants to make sure the airplane's already accelerating so he can go down the deck and airborne again, come back around and try it again. Okay. You might have a bolter in every second. I don't think you have that many bolters anymore, but things can happen. Once he lands, it's very important, like I said, he's got 40 minutes between aircraft. And even in daytime operations, what you have is a yellow shirt. It gets him over the line, it gets him over those foul lines. Remember, he's gotta be taxied. Here's the yellow shirt right there. He's standing on the other side of the foul line. That airplane lands, that's the first thing he sees. He kind of motivates the guy there. He'll give him that signal. Off the brakes. Make sure you're off the brakes. When the hook loader gets a hook tree, hook up. Taxi forward. Taxi left. Taxi right. Taxi forward. Hold your wings. How taxi toward me, go to the next controller. He's helping motivate him, remind him of things he's gotta do, because of that sequence, for the reason you have to get him landed real quick, because the ship's got someplace to go. The wind's probably not cooperating. So that's what happened to me. As soon as they can get that guy down, and get him to where the place where they're gonna park him, the chain gang comes out there, and they'll chain him to the deck, because the deck, when that deck can start moving out there, you could have an airplane slide across the deck. We've had that at one time in real high seas up in the Pacific. And so that's how the recovery, the sequence of the recovery for everyone. Any questions? Okay. This is a video that I put together, I found this on the internet, and I edited it a little bit. You should be able to see everything that we just talked about, and it should make a lot of sense to you right now, or more sense than it would if you just looked at it. So this is gonna show launch and recovery. First launch of the day, there goes the helicopter. Who's remaining? Aircraft returning up. The yellow shirt taxiing to the catapult. The green shirt's got the data for flight, for the launch. JDD goes in place. The green shirt's got them hooked up. Taking attention. Down. This is my favorite shot.
This is not the way we did it. These guys don't even touch the stick when they launch.
Yeah, they don't. It's a matter of the feedback system.
Yeah.
You can screw the launcher. There's a super tanker. That's your fueling power on the center line there. And these guys think they're fuel supply. Recovery. There's the brake in the bow of the ship. This is launching, landing at the airfield, the northern part. This is touching down. On center line. Check this out. Anytime, anywhere. And the end of the day, of course. Everyone recognize what was going on there now?
I know, it's a Charmin moment.
Can be.
So what could possibly go wrong? I mean, ever so much science has gone into this, 100 years of engineering and operations. What can go wrong is Mother Nature can get really serious out there. And it looks like a big boat, it looks like a heavy ship, but you know what? When it's out there in God's ocean, might as well be a peanut shell. This happened on my ship, 61, USS Ranger, on Gonzo Station. Or, I'm sorry, we're not on Gonzo Station yet. We're crossing the Pacific, and we're 414 nautical miles on my inertial to Midway Island. The deck was pitching they estimated 30 feet per up and down. The granger could measure plus or minus 25 feet. The gauge would peg, the check would keep going. So the LSOs thought it was about 30 feet, plus or minus 30 feet. So, what you were asking before, what do you do with that? Well, the thing we did is we had the best LSO in the Navy on the platform that night. And he brought one airplane down after another. One of the airplanes coming down with the deck, it was a little bit off. He was coming down and the deck came up a little faster, snapped his right main axle. So he's got one stub axle out there. We diverted a lot of aircraft to Midway Island. But he can't go there, he can't make Midway in that dirty configuration like that. So he's in for a night barricade with the deck pitching plus or minus 30 feet. Okay. So, like I said, Bug Roach is in control of this. That's the Plane Guard destroyer right there. Look how much the deck is pitching. He should be in the crosshairs here. That's the A6 coming up.
Is that available on YouTube?
Kidding. That's the whole
Where can
world.
you get a copy of that?
It's on the internet.
It's on,
It's on the internet.
is it?
I downloaded this from the internet. There's a couple of different versions, a short version, a long version of it.
Yeah.
If you wanna see it, you can go out here, I pointed out whenever I'm giving a tour, if it's on.
Yeah, no.
The video out here, it's got this on it.
Yeah.
As a matter of fact, you can see just the final part of this landing up there on the video over by the barricade, the plat, where they show all these these barricade engagements. This one's on there. This is the hairiest thing I've ever seen. This is the hairiest night of aviation I have ever experienced. I was in the next tanker to go. We had A6 tankers. They delayed the recovery to get fuel to the guys that were airborne. We had A6 tankers in tension on the angle deck. The deck would crash down, water would come up, wash over the A6 in tension. When the deck started coming up, the shooter fired it, and the airplane A6 went out, tanked the buddy, and they went to Midway. This was what was going on. I was the next tanker to go. And actually here at the end here, they told there was still a tanker up there. If you needed more attention to look at it, if anything had happened, I mean, it's 30-foot seas out there, we never would have found it. But we didn't know if we'd have a crash, when you fight flight deck fire, you lose an aircrew, it's just, things like that happen. See, this was an incredible example. If you go to the LSO school in Norfolk, Virginia, they will show you this. It's a legend for them up there because of Bug Roach, the guy who was ran the controlling LSO of this thing. As a matter of fact, the first time I met Sterls, And he heard I was with, the Marine Squadron, was aboard the ship, he said, "What, were you there when the bug control?" Yes, I was there, so. So, any questions?
Jerry,
Jerry.
explain to us, the jet takes off, the pilot's not touching the stick, is that correct?
On
When he
the
launches?
F-18.
What do you mean, when catapult? or
Yeah,
what?
when catapult launched.
When
I
when
noticed
catapult
that,
fires, okay,
yeah, how does the airplane compensate for that, or, and he's not actually holding the stick, really, we probably cut the throttle
With-
off,
with
but.
these guys weren't doing that. Now, every airplane had its way of doing that before we had the airplanes that we now have. Airplanes now are computer controlled, okay? And in the days of mechanical airplanes, they would take some guys would hold their hand, the stick would come back and hit it and it would bring the airplane to the right altitude. On the A6, the best climbing was 8 degrees, which you brought the horizon bar up to the bottom of the radar altimeter, or the airspeed indicator, and then you were climbing out correctly. But once you get once the catapult fires, it's gonna fly. You know, you can stand on the brakes, that airplane's gonna reach flying speed no matter what. The catapults are like that. It'll shred your tires, but you can stand on the brakes, and it works on a principle of end speed to get you the speed above stall speed. So if you go out there, once you get out there, you keep the airplane will take off level like that. Now, or you with that 8 degrees, 8 degrees nose up. The problem you have nowadays, airplanes are controlled by computers. There are 3 computers in there, and each computer is hooked up to its own set of sensors. The sensors give you 3-axis acceleration and 3-axis roll indications, okay? So what a computer does now is, each one of these computers have the same program, they call them control logs, all right? Now, when a pilot moves the stick, if you move it so far so fast, the computer says, oh, he wants the airplane to do this, and it puts controls in that will do that. And with our F-35, if it isn't responding correctly, it'll find another control surface and put it in till it does respond correctly. So when you're launching like that, you can put the wrong input in, or the huge inertial forces you have can tell the computer erroneous information. It might pull the nose up way higher or something like that, because and stall the airplane. So they have to put in a special algorithm in there, a special set of flight controls. Don't touch the stick, and the computer, once you configure for takeoff like that, I don't know how they do that. Maybe when the launch bar is down or something like that, and when the stroke starts, the airplane will automatically fly to that, because it'd be too dangerous to have it fly any other way. But that's why they put their hand up in the air. They keep their hand on the throttle, because you got a catapult grip. You don't want that to come back by inertial forces. But they don't touch each other now with these feedback, because of the feedback loops for each one of the computers. That's why they do that.
I see.
Yes, sir.
In your opinion, what are the best qualities of a good LSO?
Well, I'm not an LSO. I take that back. Everyone aboard the ship that watches the plant is an LSO. They get to where they criticize everyone.
No, but as a pilot, though, what's-
You have to. It's a set of skills to have a feeling for what the ship's doing, and take in the motion of the airplane at the same time. Bud Roach, when he did this down there, he was taking in on a critical emergency like this. He looked at he made it sound, had a calming voice. And if you heard him there, he made this sound like it's a regular syllabus hop. You know, okay, it's your turn to make a plus or minus 30-foot landing. It has to be calm, reassuring, and it has to have a trust between the pilots. You know, if the pilot sees that the LSO is right, he'll give him trust. And I think it's someone like that that is technically competent. He can see, yeah, the nose is going high, and he can see the different speed changes better than the other guy. I've heard it that a good LSO, top LSO, can see 2 knots of change in speed. So that's what I mean by a technical skill. I'm not an LSO, but I know certain guys out there on the platform, their voice comes across, and you trust them because they've made good calls for you. You can see where the mistakes are being made during the day, so you trust them more at night. Is that what you would think?
Yeah, plus they get to know the air wing. I mean, there's only
Yeah.
150 guys, so pretty soon you start to know, you know, and you know the ones that are better and the ones that aren't quite as good, you know.
Some people don't, we've had some LSOs that no one agreed with them, they didn't like him. Everyone enjoyed when Bud was doing it because he was good, he reflected what, the pilots trusted him, they trusted him, they knew his calls, and he was quite a character. I mean, the ice machine broke aboard our ship, but not in Bug's room, because Bug had an ice machine in his machine, you know, he had cruising down to the science. I couldn't go any further than that. I would know if I trusted a guy or not. So, any other, yes ma'am?
For the newer modern carriers, the modern latest that have been built, what is, some of the changes that have been made that differ now on the carriers for the deck itself? Are the dimensions the same? What's happening with the new carriers?
The dimensions are not much different. The carriers are about 1,100 feet long. And I went to visit the Midway out in San Diego. It's a fabulous museum if you've never been there. They just do a great job of showing what the Midway class was. Now that was a World War II aircraft carrier called the Essex, and they did a change called the 27 Charlie. And they widened the deck so now you had an angled flight deck, and made the thing was about 300 feet longer. But it waddled through the ocean in a really hazardous way. And that got me a free trip to Team Spirit over because Midway couldn't hack it. But I visited that ship, and then in San Diego at the museum, and then the Reagan had just come to town. Now the Reagan is a top of the line new ship, and it wasn't the length that different. It's the volume. There's so much. It was so much beamier and had so much more. Not the drainage, the draft is bigger and you've got more volume to the ship, more displacement to the ship. So there's more room aboard the ship. Nuclear powered, and that now everything's nuclear powered because you've got 20 years of fuel inside that thing. You're not hampered with by fuel requirements. And now the newest thing is they're switching the catapult and arresting gear are being made electromagnetically. Now that's the Ford class. If you look at the Ford class, we've got a model out here. One of the other things is the island. Well, first of all, the electrical arresting gear, electrical catapults. Now, they're having some growing pains with them, I know, but I visited the Ford, and the green shirt chief took me around, and he said he loved the electric catapults until they broke. But they're having some trouble with the maintenance and breakdowns of it. So, but that's going to be the future right there. That's a big change. And if you look at our model out here, you'll notice the island is way far back on that. The Nimitz aircraft carriers that we saw here, they have a lot more parking space in front of the island. I really envy that because it gives you more room to move the airplanes around. And during, not cyclic ops, but if you have to do what they call the flex deck, because combat operations, you need that space to move things around. That's a big difference right there. That's the biggest thing. And I guess they can take electrical energy and pipe that around the ship a lot easier than they can take steam and pipe it around the ship. So that would be big changes right there. They're also giving the pilots, the airplanes now have precision, what's the term they use? Precision landing mode, PLM. And the airplane, I can say Lockheed Martin, my boss at my folks at the Skunk Works, they pioneered that. And what they did, they integrated, when you're flying the ball like this, they integrated the flight controls with the power. And what happened with that was they integrated with the ailerons. So if you had one in power, you add power like that, and you didn't wait till the end of this blow, you got an almost immediate response because the ailerons dip like this. So you had, it was DLC. It was a form of DLC hooked directly to the throttle, and what it did, it drooped the ailerons down like this, so you got immediate aerodynamic lift, and it worked like a charm. Boeing has copied that now. They've copied it into what they call magic carpet, by integrating the throttle when you're on the approach, taking the throttle and integrating that with flight control to get a much better response. So there's the precision landing modes. As a matter of fact, now they're talking about not teaching the power and approach anymore, because they don't think they need it. The automatic systems are taking that over and doing it better than the Bible. As a matter of fact, at the LSO school, the last time I went there was like 2 years ago for an A6 reunion, the guy giving the brief, he said, "We don't fly the ball like you do. You know, with the throttle and everything like I just showed you up here? We look at the impact point. That's where the airplane's going. We use everything the airplane has. You guys are stuck with, you had to use the power fly, that optical landing system and that. You've got more features in the airplane now to help us get it precision landing modes and better heads-up displays. We didn't have a heads-up display. So this technology is taking over now. I think they still should teach the manual power approach, because someday soon, Murphy's Law says it's gonna break. It's gonna break, yeah, and it will. Anything that can go wrong will go wrong. And everything gets worse before it gets better. Any other question? Well, in that case, thank you. If you have anything you want to talk about afterwards, be glad to talk to you.
Round of applause
That-
for the outstanding.